Excuse me. All right. So, look at some what we're going to call ratios. Um, and so when you hear the word ratio, think fraction. And we'll start. This is going to be titled 4.1. And so I'm going to go through and just look at a few problems that we deal with ratios and arithmetic associated with. Now it says we're going to write ratio as a fraction in lowest terms, and we've got 1 5/7, 2, 3 1/4. So we're going to have 1 5/7, 2, 3 1/4. All right. So which turns into division. So the first thing I want to do is rewrite each of these in improper form. So remember that take a mixed fraction to an improper form, 7 times 1 plus 5, which would give me 12 over 7. And then this is going to be over 3 times 4 is 12, plus 1 is 13 fourths. Okay. Now, so we've got 12 sevenths divided by 13 fourths. So first off, when you get a ratio in this form, top to bottom, or more fancy, numerator to denominator, top to bottom. And if we have mixed fractions and we're doing division or multiplication, rewrite them in proper form. So I've done that. And then this will be the top times the flip, or what we call reciprocal of the bottom, which would be 4/13. Now, nothing here is going to cancel. 12, 13, you're going to factor 7, 4, so it's just multiply across the top, which is 48, 12 times 4. And then 7 times 13 is 91. And that would be it. That would be your answer, 48 91st. Any questions on that? All right, that is actually number 2 that we worked out there. Okay. And you should be up. 1 second. Here. Excuse me. So so you are correct. And yeah, and so that was where I had first said, "Are there any questions?" And so I still will entertain that if you had some questions from 3.1. So there are 2 more sections that I probably was not clear on this as I should have been. If there aren't any questions, I went ahead and decided I wanted to look at, I'm sorry, like something caught in my throat. I did not assign those. And what I decided to do for today was skip over those and move to 4.1. Um, we're in a position where everything that I have here, there's no way with the days we have left, we're going to be able to work through everything. And then just looking at what we're going to be doing in 120 down the road, I wanted to look at ratios, in which also then will come back to percentages. So if that's okay, as long as there was no questions on 3.1, there is a section 3.2 and 3.3 in a quiz, but I'm bypassing those right now and moving into 4.1. And that's so the next thing you see come up on your assignments are going to be these problems that we're looking at um, from 4.1. So, and I wasn't clear about that. I apologize. All right. So were you okay with the ratio I just worked here? All right. So okay. So let's see. Okay. Shoot. Give me a second here. I'm having. All right, there we go. All right, so moving to number 4. Find what we're going to call the unit rate. And right, so whatever the units are, whether it's hours, minutes, feet, inches, um, minutes, seconds, hours in this case, um, we're talking per unit. And so in this particular case, we were $120 in 6 hours. So we would say, well, um, what is the unit rate? And so 120 divided by, so, and I could probably write this up a little bit differently. $120 per what? 6 hours. I don't know why I've got a 60 there. And then I get that dollar per hour. And then it's just a matter of doing the arithmetic. So much like, when we were looking at feeding into that idea of unit analysis. So we end up with $20 per hour. That would be it. That would be your answer there. Okay. So I'm going to jump to number 6. Now it gives you 3 different choices here. 16 ounces for $3.79. 27 ounces for $5.19, and 31 ounces for what was it, 5.39. Now, generally speaking, the more you buy, the better the deal in terms of unit price. Now, if you most grocery stores that you go to, you can look at the little price tag and they will have calculated on there what the unit price is. And that is we're looking at, how much, per one unit in this case. And usually that's in per ounce. But don't bank on two things. One, don't bank that the largest quantity is going to give you the best deal, that is per your unit price, or price per unit. And two, don't bank on the fact that the numbers they're giving you, they're probably right, but mistakes happen. So, and I'm just one of those individuals never trusting. Now, so that what it basically means is I need to break this down to figure out which one's the better deal to the price per unit in this case, which the units are ounces here. So I took 3.79 divided by 16. So doing the same thing that I did here, breaking it down, my calculations, I guess I have more room here. $3.79 per what? 16 ounces. And that's going to come out to 0.236875. Now, of course, rounding that to cents, 0.24. And this again, dollars per what? Ounce. And then we would do the same calculation for each of these two. So if I went 5.19 divided by 27, I just got a little bit better. So I'll put right here 0.24. Per ounce. This one came out to 0.19, so it's better per ounce. And then 5.39 divided by 31 comes out to rounding $0.17 per ounce. So in this case, it is the largest amount is the best deal. Okay. Next problem, number 7, it's the same thing, except it's 4 different. And this is jars of peanut butter. And I'll just tell you it's not the largest one is the best deal, but the calculations would be the same. So in case it's a dollar amount divided by the number of ounces to again get your cost per unit. In this case, dollars per ounces. Let's find another problem here. So moving on to number 9 deals with proportions. Very quickly, proportion are 2 ratios set equal to one another. And number 9 just basically asks, is it true or false? Now, you're given 6/15 equals 3/8. There's actually a couple of ways I could go about figuring out whether this proportion is true. These 2 ratios are equal to one another. Remember, a ratio is a fraction. Ergo, every fraction can be written in lowest terms. So if I put them each, and that's what it asks you to do here, put them in each in lowest terms. Here, top and bottom have a common factor of 3, which means 3 goes into 6 twice, 3 goes into 15 5 times. And then is this true or false? Well, that's not equal. Hopefully, if 2 fractions are only equal if the tops or bottoms are equal and they're in lowest terms. So false. All right. That is one way to determine. Just write each and lowest terms, and then the fractions have got to be identical if that proportion is true. Now, but there's another way. So I'm going to write a rule here. If you've got a fraction a over b, and it equals a fraction c over d, then a times d, so I've written this up so there's no multiplication symbol there. It's understood to be multiplication. That is, this product has to equal that product. We use the term cross multiplying, and kind of coming from that, or the product of this diagonal has to equal the product of that diagonal. And it door goes both ways here. If AB equals BC, then it's got to be true that A over B equals C over D. So in this particular case, if I were, it was probably easier just to reduce this real quick and say, okay, it's not true. However, I could have went 6 times 8 is 48, and 15 times 3 is 45. 48 is not 45. I conclude that this proportion is false. All right, so here's another one. This would be number just 10. And I'm given 20 over 28. And is that equal to 30 over 36? Now, again, I could just reduce each of these. But I could real quick just look at 20 times 36 and see what I get there. And I could punch it up on my calculator. And I'm going to get 720. And then look at 28 times 30. And that is 840. And that's enough right there, without reducing the fractions, to claim it's false. Okay. Okay. Then you got one with mixed fractions. Should be able to handle that. Let's go ahead and do it. I'm going to turn the page. So number 12, I've got 3, 5, 6 over 9 2/3. And this claim is it equal to 23/58. Okay. Now, so again, I could just look at the cross products. That is, all right, let's just look at 3 and 5, 6 times 58. Now, I'm doing this arithmetic. I would do this. First, I got to convert that to improper. So 6 times 3 is 18, plus 5 is 23 over 36. And when I say times 58, that can be written as 58 over 1. Now, multiplying 20 across the top, 23 times 58 is 1,334. Now, bottom is 36 times 1, so it's 36. Then I'm going to do the same thing, except for the other diagonal product. 9 2/3 times 23. Again, I write this as improper. 3 times 9 is 27, plus 2 is 29. Oh, gee. Jiminy, oh, little tiny mistake. I don't know why I wrote 36 there. Other than I just probably grabbed that 3 and wrote 36. It's always this times this plus this over that denominator, which was 6. So, all right. So, yeah, fixing that as 29 thirds. 3 times 9 is 27 plus 2, 29 over 3 times 23 over 1. All right. So, we have 3 in the bottom. And 29 times 23, 667. Now, here's the deal. I look at these two. Don't just say, oh, it's false. This might reduce. This might reduce. Now, 3 is prime. 3 does not divide evenly into 6, 6, 7. It's not a factor of. So this is reduced. This is even, which means 2 is going to go into it. That's even. 2 is going to go into that. And when you divide 2 into 1334, you get 667, and 2 in the bottom is 3. So this one is true. Cross products are equal. Questions on that one? All right. So let's look at, I'm jumping ahead to number 14. I've got 2 and 1/10 over 7.35 equals 3/4 over 2.7. And so I'll do same thing. Now, when I look at the diagonals, notice what I'm going to end up with is I have a fraction here. I have a number in decimal form here. And what I always say, it actually doesn't matter which way you go with it. Either write them both as fractions or write them both in decimal form. So what I'm going to do, I think, is put them in decimal form. Now, if you go 1 divided by 10 on your calculator, you get 0.1. So 2 and 1/10 in a decimal is 2.1. So on my calculator, I'll just put in 2.1 times 2.7. And which comes out to 5.67. Then I'm going to do the same thing here. I'll have 7.35 times 3/4 in decimal form is 0.75. So 7.35 times 0.75 is 5.5125, and that's enough right there. Those cross products are not the same. So not equal. Questions on that one? Okay. Moving to number 15. And what we're going to have here, this is the first time we have looked at something like this. We're going to find the unknown number. Now it's a proportion, and we know that the cross products have to equal. But we have what is called a variable. That is, x could be any number. But we want to find the one number that makes that equation true. This is the first time where we really have looked at what we might call an algebra problem. Now, the word algebra itself, don't let that scare you. It just honestly is looking at the 4 basic algebra. What is algebra? It's the study of the 4 basic operations on sets of numbers. But what would the manipulation look like to figure out what x is? Now we know the cross products have to equal if this proportion's true. So that tells me 24 times x, and I'll write it that way, 24x. It's understood, no symbol between, it's multiplication, has to equal 18 times 8. All right, so let's see where we could go with this. So that would take me to 24 times x equals, now 18 times 8 is 144. All right. Now we have a rule about equations. We actually have two rules. And we can add the same number to both sides of an equation and not change the equation. And by the same token, I can multiply both sides of an equation and not change the equation, provided I'm not multiplying by 0, because if I multiply both sides by 0, I end up with nothing. I'd have 0, which is true, but that doesn't tell me what x is. Now, what I'm going to do is this. I want to look at what I call two sides of the same coin. So I'm going to jump down here, and I want to look at this 24, just this 24x. Now, in multiplication, reciprocals always multiply to be 1, and 1 is what we call the multiplicative identity. 1 times anything gives me that thing back. So 1 times 8 is 8. 1 times 9 is 9, etc., etc. Or excuse me, 1/8 times 8 is 1. 2/3 times 3/2 is 1. Reciprocals always multiply to be 1. So the reciprocal of 24 is 1/24. Now 1/24 times 24 is 1. And since 1 times anything is itself, 1 times whatever x is x, I can just write that as x. Now, it's the same thing if I say 1/24 times 24 is 1, as if I say 24 divided by 24, which a number over itself, other than 0, because you can't have 0 in the bottom, is 1. So whether I say multiply both sides by 1/24 or divide both sides by 24, I'm really saying the same thing either way. And it's really, it's a preference of what you prefer. Now, most people prefer this, writing it this way, because it's a little more efficient to write. Where you have to be careful is if you have something like this. Now, you can say divide both sides by 3/2, because we know we flip the bottom and multiply it by the top, and the flip of 3/2 is 2/3. But so if I have a fraction in front of x here, 3/2 times x, I'm more apt to write it as multiply by the reciprocal as opposed to divide by. And I'm so bad about transposing numbers. Should have been 2/3. I'm more apt to write it its reciprocal times this, as opposed to, I'm not going to even write it 3/2 divided by 3/2, which ultimately would become this. Now, the reason I said this is I'm allowed to multiply both sides or divide both sides of an equation by the same thing and not change it. So whatever this number is, I choose to divide both sides by it, so that this is just a factor of 1. It leaves me with my x. And then I just do the arithmetic here. What is 144 divided by 24? And it does go evenly. In this case, it is 6. So we used what we learned about cross products of proportions, and a little bit of what we call the multiplication division rule for equations to solve a little tiny algebraic equation. Any questions on that? All right, so let's do one more like that. So number 16, we're given t over 30 equals 12 over 72. So cross multiply, 72 times t has to equal 30 times 12. So 72t. Now 30 times 12 would be 360. And then we're just going to say divide both sides by 72. 360 divided by 72. And I get t here and 5 there. And so t is 5. All right. And we're going to do one more and just make the numbers a little bit more interesting. Let's say I've got 5 1/5 over 6 1/6. And this equals s over 7 1/7. Now, process will be the same. I'm going to say this diagonal. So 6 1/6 s equals then 5 1/5 times 7 1/7. All right, so the first thing I'm going to do is rewrite these fractions in improper form. So this would be 37/6 s equals, this would be 26/5 times 57. All right. Then I would have 37/6 s equals, then I could go ahead. Now, what I would do here, since 5 goes into 5 once and 5 goes into 50 10 times, we can go ahead and reduce this thing before we multiply, make the numbers a little smaller. 7 does not go into 26. Note that 7 is prime. So now 26 times 10 is 260. And 1 times 7 is 7. So here is an example where I wouldn't want to say divide both sides by, because this number times s is a fraction. I would just go ahead and say multiply both sides, because you have to, you choose 6 over 37 because that's the reciprocal 37 over 6. They multiply to be 1. And we're good as long as I multiply the other side by 6 over 37. So here, and everything cancels, leaves me with 1. So I got my s. And then here it's multiply it out. Now, it does not appear 37 is prime. I'm going to check to see if it's divisible by 37. It is not. So if I multiply the top, 260 times 6, I get 1560. 37 times 7 is 259. Now, I'm looking at the answer here, and it's putting this in as a mixed fraction. So, which that means to convert to a mixed fraction, take your 1560, divide it by 259, and I get 6.023166023. So it goes 6 point and yada, yada, yada. So I know the whole part of the mixed fraction is 6. Now this will be over 259. It's a question of what was the remainder of the division. All right, so that's where I'm going to go 259 times 6. I get 1554, which when I take 1554 away from 1560, I get a remainder of 6. Right, so process is the same, cross multiply, you know, multiply these two together, and then multiply both sides by the reciprocal of this to isolate S. It's just, it was more interesting because the arithmetic was a little heavier on that one, but process still is the same. And then the last two, basically the same. So I'm going to go ahead and assign 4.1. It is now assigned. It's 20 total problems dealing with these ratios and proportions and the arithmetic thereof that we've just covered. So I've done an example, at least multiple example of everything in this section. There's 20 problems. I put the due date to be 7/11, same as the others. So are there any questions you have? Okay.